Good morning, students. Write your name and your seat number in the chat box. So last lecture we are discussing with the methods of preparation of chlorine and the reactivities of chlorine. So for the board examination, this decon process is very important. Manufacturing of chlorine, I also explained the manufacturing is this process is used for the industrial preparation of chlorine, and this preparation of chlorine means these are the laboratory methods. In laboratory, how the chlorine is prepared by using manganese dioxide and potassium permanganate. This is prepared by the oxidation of hydrochloric acid, manganese dioxide plus hydrochloric acid. It gives MnCl2 plus Cl2 plus twice H2. So these two methods are used for the preparation of chlorine in the laboratory by using manganese dioxide, by using potassium permanganate, and this one is the action of H2SO4 with sodium chloride, that is a common salt, and manganese dioxide. These are the two reactions. These two reactions combined together, we will get here chlorine. So these are the methods of preparation of chlorine in the laboratory, and this is manufacture of chlorine. We can also prepare chlorine for the industrial purpose by two methods. First one is by decons process. Generally, the question is asked for decons process. The chlorine is manufactured by oxidation of hydrogen chloride here. By using atmospheric oxygen in presence of catalyst CuCl2, we get here chlorine plus H2O. And another method is electrolysis process. This is when the solution of brine is a concentrated solution of NaCl, when undergoes electrolysis, when two electrodes are dipped here. In this diagram it is shown, one is anode and one is cathode. And when the electric current is started, the chlorine is the chlorine molecule, chlorine gas is liberated from this anode and from this cathode. You can see clearly here, hydrogen gas is liberated, and here on anode, the chlorine gas is liberated. So these are the industrial methods, remember. For industry, for the preparation of chlorine, these are decons process and electrolytic process, these are used. Now the physical properties of chlorine, how the chlorine molecule, chlorine gas looks like. Externally, it is a greenish yellow colored gas having the pungent and suffocating odor. The odor is very dangerous odor. So chlorine is a poisonous gas, remember. It can be easily liquefied into greenish yellow liquid, which boils at the temperature 293 Kelvin. Then it dissolves in water to give the chlorine water, and this chlorine water it is used in many reactions. In halogen derivative of alkenes, we seen this bromine water and chlorine water. It gives the product 2,4,6 tribromochlorine. If it reacts with chlorobenzene, it gives the products 2,4,6 trichloro. 2,4,6 trichlorochlorobenzene. So chlorine water, how it is prepared when the chlorine gas is dissolved in water. It is heavier than air, 2 to 4 times it is heavier than air. Then these reactions, when the chlorine gas reacts with metals, they forms the metal chlorides. We'll see this example. When chlorine gas reacts with aluminum, they give aluminum chloride. When they reacts with sodium, they give sodium chloride. When they reacts with Fe, FeCl3. Then reaction with non-metals, also chlorine reacts with non-metals too from these chlorides. When chlorine reacts with phosphorus, they give phosphorus trichloride. When they reacts with sulfur, they gives the sulfur chloride. Then reactivity towards hydrogen. Chlorine can react directly with hydrogen or the compounds containing hydrogen. Here, chlorine reacts with hydrogen to form hydrochloric acid. It is a very well-known gas. Also, when the chlorine reacts with H2S, H2S is a rotten egg smell. It is also the poisonous gas. So this chlorine reacts with H2S, hydrogen sulfide. It gives twice HCl plus sulfur. We are discussing this reaction in the last lecture when excess of ammonia reacts with chlorine and excess of chlorine reacts with ammonia. These are the two different reactions. In the first reactions, we are using excess of ammonia. 8 molecules of ammonia reacts with 3 molecules of chlorine. We get here NH4Cl, ammonium chloride, and nitrogen. But when the proportion is reversed, when the chlorine is used in excess with ammonia, they gives it is a NCl3 is a nitrogen trichloride. NCl3, it is a nitrogen trichloride which is explosive in nature. Then reaction with hydrocarbons. When chlorine reacts with methane and when chlorine reacts with ethane in halogen derivatives, also these reactions are completed. So this is a free radical mechanism reaction when methane reacts with chlorine in presence of UV radiations, they give methyl chloride. We can't get a single product. Reaction stops at when all the hydrogen molecules are replaced with chlorine. So in this reaction, we get more than one products. Then for ethene, this chlorine reacts with ethene. Reaction takes place across this double bond. Double bond is broken and it is converted into single bond. We get 1,2-dichloroethane. These reactions are completed in halogen derivative also. Then reaction with alkali, reaction with base. When this chlorine reacts with NaOH in cold and dilute condition, they gives a mixture of chlorides. This is a sodium chloride and this is a sodium hypochlorite. So they gives mixture of chlorides and hypochlorites when the alkalis are cold and dilute, because there are two conditions. Alkali, when the alkalis are hot and concentrated, and when the alkalis are cold and dilute, they gives the mixture of chlorides and hypochlorites. But when the alkalis are hot and concentrated, they gives a mixture of chloride and this is a chlorate. NaClO3, it is a chlorate. NaOCl, it is a sodium hypochlorite. Remember, NaOCl, it is a sodium hypochlorite, and this is a sodium chlorate. This is a difference. Also, when chlorine reacts with calcium hydroxide, this calcium hydroxide is also called as slaked lime. When this chlorine reacts with calcium hydroxide, it is also called as slaked lime. They gives bleaching powder. So this is a calcium chloride, CaOCl2. This is a bleaching powder, remember. Then oxidizing property, chlorine oxidizes ferrous salts to ferric. So FeSO4, ferrous sulfate, it is converted into ferric sulfate. Also, this is a sodium sulfite, it is converted into sodium sulfate. So chlorine having the property of oxidizing property, it oxidizes ferrous salts into ferric. And this is a sodium sulfite, it is converted into sodium sulfate. Then it oxidizes sulfur dioxide to sulfur trioxide. See here, SO2, it is a sulfur dioxide, it is converted into sulfur trioxide, and iodine is converted into this. See, this is iodine, H2I2 is iodine, it is converted into iodate, HiO3. In presence of water, they form sulfuric acid, and in presence of and iodic acid is in presence of water. See, these reactions are given in presence of water, they form sulfuric acid, and in presence of iodine, they give HiO3. HiO3, this is a iodic acid. Then how chlorine bleaches? This bleaching property of chlorine is due to the presence of nascent hydrogen, remember. And how this nascent hydrogen is generated when this chlorine reacts with water, means in a moist condition or in presence of moisture, they give a mixture of HCl and HOCl. This is a hypochlorous acid. So HOCl, this HOCl is responsible for bleaching. This HOCl gives mixture of HCl and this oxygen. This is a nascent oxygen which bleaches vegetable matter or colored organic matter into colored organic matter into decolored matter. So this colored organic matter, it is converted into colorless organic matter due to the presence of this nascent oxygen, remember. So this nascent oxygen is responsible for bleaching action. So for 1 mark, the question will be asked for the board examination. Remember, this is IMP for exam. Explain the bleaching property of chlorine. So chlorine having the bleaching property in presence of moisture. So first one we have to write this reaction. Chlorine reacts with water. It gives HCl plus this HOCl. This HOCl is important for us. Hypochlorous acid. This hypochlorous acid gives HCl plus oxygen. So this is a nascent oxygen, single oxygen. It's called as a nascent oxygen, which decolorizes vegetable matter or colored organic matter into colorless organic matter. So remember this bleaching property, important reaction. Then I am coming to the uses of chlorine. This chlorine gas, it is used for the purification of drinking water. Then second one, it is also used for the bleaching of wood pulp. This wood pulp, it is required for the manufacturing of paper, rayon, bleaching cotton, and textiles also. So for the extraction of metals like gold and platinum, this is used in the manufacturing of dyes, drugs, organic compounds such as CCl4, carbon tetrachloride, CHCl3. This is chloroform. Then DDT, which is banned now. DDT, it is also given in chapter number 10, halogen derivatives, and refrigerants. Then next one, it is also used for the preparation of poisonous gases such as phosgene gas. So these are the very dangerous gases used for the war condition. When the war is there or when the riots are there, these gases are used. Phosgene, this is a poisonous gas. This is asked for the examination for 1 mark. What is the formula of the phosgene gas, what is the formula of tear gas, what is the formula of this mustard gas. So these are the 3 gases, phosgene, tear gas, and mustard gas. These are used for the war condition. When the war conditions are there, these gases are used. So phosgene is having the formula COCl2, then a tear gas. This is a CCl3NO2, this is a tear gas. And then mustard gas, this is having the formula CH2CH2Cl, then sulfur and CH2CH2Cl. So you have to remember these formulas and name of the gases. because for 1 mark it can be asked for the examination, because the names are given: phosgene, tear gas, and mustard gas. Then interhalogen compounds. Now the chlorine compounds are completed. Now I'm coming to the last part of this chapter, interhalogen compounds. You know, the name itself suggests interhalogen compounds are the compounds when two halogens combine together. It is called as interhalogen compounds. So all the halogens are belong to the group number 17. Though they belongs to the group number 17, they having some capacity to form interhalogen compounds due to the difference in electronegativity. Because electronegativity difference of fluorine, chlorine, bromine, iodine is different, so they can combine each other to form the interhalogen compounds. So due to the difference in electronegativity, two or more halogen atoms combine to form the species which may be ionic or neutral. So the neutral molecules are called as interhalogen compounds. For example, it is given Cl, it is one halogen, fluorine is also another halogen, bromine, fluorine. So always these interhalogen compounds are formed with combination of atoms of different halogens. Out of these two, one is electronegative and one is electropositive. So I will explain which is electronegative and which is see, these interhalogen compounds are formed in which one halogen is highly electronegative. You know, fluorine is highly electronegative, and this chlorine is less electronegative than fluorine. So all the interhalogen compounds are formed by this condition. Out of these two halogens, one halogen having the higher electronegativity and one halogen is having the lesser electronegativity. So the various types of interhalogen compounds are shown here. These are the interhalogen compounds of chlorine, ClF, ClF3, ClF5. Then these are the interhalogen compounds. These are the fluorides because fluorine is combined with bromine. So bromine, when it combines with fluorine, BRF, BRF3, BRF5, BRCl, this is a interhalogen compounds with chlorine and bromine. Then this iodine having the interhalogen compounds IF, IF3, IF5, IF7, ICl, ICl3, IBr. Means iodine, you know, the electronegativity of iodine is very less. So iodine forms compound 1, 2, 3, 4, 5, 6, 7 interhalogen compounds, maximum interhalogen compounds with formed with iodine because it is having the very less electronegativity and fluorine is having the higher electronegativity. So depending upon the composition, the interhalogen compounds are classified into 4 types. So these are the 4 types. First type is X dash, means only single molecule is there. X dash 3. X dash, I will explain what is this X and X dash. So X is a halogen with a larger size and more electropositive, remember. It is a more electropositive. Cl is electropositive, means its electronegativity is less. And X dash, this X dash is a fluorine. This is halogen having the smaller size. You know, fluorine is having the very small size. So X dash is smaller size and more electronegativity. So depending upon this composition, X dash composition, interhalogen compounds are classified into 4 types. First type is X dash. Say this is chlorine is X, this is X dash, X dash, BRCl, X dash again, X dash. Now you know X dash is a high electronegative and it is smaller size. Again X dash 3. In this X dash, there are 3 molecules of fluorine: ClF3, BrF3, and IF3. Then third type is X dash 5. Fluorine having the 5 molecules: ClF5, BrF5, then IF5. and X-7 there is only one compound, that is IF7. So this is a classification of interhalogen compounds. Then the general characteristics of interhalogen compounds. First characteristic, the compound are considered as the halide of X. For example, ClF. Here, one halogen, this chlorine is having the larger size and fluorine is having the smaller size. Then I am coming to this one. As the ratio of X and X dash, radius of X and radius of X dash increases, the value of En is also increases. Means when the radius of X is having the halogen which is having the larger size, it is also electropositive, and X dash. When this ratio increases, the value of En is also increases. What is this En? Means the number of compounds formed indicates by this N. So interhalogen compounds have the even number of atoms, 2, 4, 6, 8. This is the example ClF3. It is having the 4 atoms, 3 fluorine atoms and 1 chlorine atom. So always interhalogen compounds are with the even numbers, always 2, 4, 6, 8. Also we can see in this table also the number of atoms are 2 here, the number of atoms are 4 here, the number of atoms are 6 here, and the number of atoms are 7 plus 1, 8. Means always interhalogen compounds have the even number of atoms, 2, 4, 6, and 8. The properties of interhalogen compounds are generally in between those of halogens from which they are made. Means if we consider this example ClF3, this interhalogen compound having the properties in between chlorine and this fluorine. The central halogen exhibits the different oxidation state in different interhalogen compounds. The number of X dash atoms in the compounds are always odd number. Remember, X dash number is always odd. It will be 1, 3, like this, 1, 3, 5, like this. So in this X dash is 1, X dash is 3, in this X dash is 5, X dash is 7. So remember, the X dash atoms are always odd and they all are diamagnetic. So these are the some general characteristics of interhalogen compounds. Then in this diagram, the states are given in which states of matter the interhalogen compounds exist. This is one important thing is shown here, because on this part you must know this part, because the question is asked for the CET also, for the JE also, and for the NEET also. X dash compounds are more reactive than X2 or X dash 2. Remember, means these interhalogen compounds are more reactive than normal halogens, or X dash 2 means X dash 2 means all the halogens are same here, X2 and X dash 2. This X dash compounds are more reactive. Why this is reactive, I will explain. Because in the X and X dash bond, X dash is more electronegative. You know, this is a more, we will take this example of Cl and F. This fluorine, this is Cl is X and X dash is fluorine. So this fluorine is more electronegative than this chlorine, than X2, general Cl2 molecule or F2 molecule. So the more bond energy, hence X dash bond energy is less than X, normally XX. So this bond can be easily broken. So this is the more reactive than the Cl2 molecule. The question can be asked for the examination, which of the following is more reactive? They will give ClF and they will give Cl2, or they can give F2. So remember, this bond, the bond energy required to break this bond is very less. So it can be very fast react. Reactivity is very fast. When the reactivity is more, when the bond is easily broken, they are reactive. When the bond is not easily broken, means the bond dissociation energy is more, these are not reactive. So this question is asked for the examination, why the interhalogen compounds are more reactive than the normal halogens. And the reason is bond dissociation energy, or this bond is a weak bond, remember. This is easily broken. So these are the some states of interhalogen compounds are shown at 25 degrees Celsius. You can read at your home, because this is not much more important for the examination. Then this is important for the examination purpose, how this intermolecule interhalogen compounds are prepared. So this is a direct combination when this Cl2 molecule and F2 molecule, when these are in equal volumes, Cl2 and fluorine, they are in equal volumes at the temperature 523 Kelvin. In copper vessel, this reaction is carried out. We get, this is the interhalogen compounds of chlorine and fluorine, twice ClF. Another example is I2 plus Cl2. This reacts in presence of strong hydrochloric acid and strong nitric acid. They gives twice ICl. Then Br2Cl2. These are this is the direct combination of two halogens. Br2 plus Cl2. They gives twice BrCl. So this is XX dash are prepared by using this method, XX dash. Then XX dash 3. XX dash 3 is prepared. One example I will discuss, Cl2 plus thrice F2. In excess, they gives twice ClF3. This is Br2 plus thrice F2. They gives twice BrF3. Then I2 plus Cl2 gives twice ICl3. Then this is the reaction of halogen with interhalogen compounds. When this Br2 plus BrF3 reacts, they give the thrice BrF. Then this is a special reaction for ICl. I2 reacts with KClO3, they give ICl plus KiO3. So this is methods of preparation of interhalogen compounds. We have to make a practice at your home, right? How this XX dash is prepared, how this XX dash 3 is prepared. And these are the uses of interhalogen compounds are there. So on interhalogen compounds, 1 mark, at least 1 mark question will be there. The question will be either for the preparation, or question will be asked on the uses, or question will be asked on what are interhalogen compounds for the definition. So remember, for 1 mark, the question will be asked on interhalogen compounds. Either the question will be on the uses, or question will be on the preparation, or question will be on definition. So make a practice at your home. What is mean by these interhalogen compounds? This is not very difficult to understand. This is very easy. So the uses I will discuss only the 2 uses. Remaining uses we can read at your home. This XX dash. So this ICl is very important. ICl, it is used to determine the iodine value of oils. As it is a catalyst, it is used for the oxidation of arsenic 3 plus for the preparation of polyhalite. This is used. Then XX-3 for the preparation of polyhalides, it is also used as a fluorinating agent. And then I'm coming to the next part. Some properties of interhalogen compounds thermally. This is the ClF is more stable than BrF. ClF, this is ICl, then IBr, this is BrCl, BrF. This is thermal stability. These are the reactions when the interhalogen compounds reacts with water. When this BrCl reacts with water, they give hypo. This is hypothymia. Then this is hypoxia. 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 Then this is hypox this Ichobrium hypobromous acid. When this ICl reacts with HiO3 is iodic acid plus 5HCl plus twice I2. This is a disproportionation. Autoionization takes place. BRF gives twice BR2 plus BRF5. These are the properties of X-3. When this ICl3 reacts with water, they give HiO3 plus 5HCl plus ICl. So student, don't take attention of this because this is not asked for the examination. These properties will not ask for the examination. But these structures are very important for the examination point of view. Remember, these structures are 100% asked for the board examination. Draw the structure of this ICl. This is a linear structure, remember. ICl, this is the name of this interhalogen is iodine monochloride. Iodine monochloride. This is a chlorine trifluoride. This is bromine trifluoride. This is bromine pentafluoride. This is chlorine pentafluoride. So see how the names are given. First halogen, we have to consider iodine. So the name is iodine monochloride because single chlorine molecule is there. Then this is a chloride trifluoride. Sorry, this is a chlorine trifluoride. When printing mistake is there, this should be chlorine trifluoride should be there. Chlorine trifluoride, this is a bromine trifluoride, this is a bromine pentafluoride, this is a chlorine pentafluoride. So I will discuss these structures. First, this ICl, iodine monochloride, these are having the linear structure. See, the linear structure is shown. Then this is the ClF3, chlorine trifluoride. This is a bent T-shaped structure. This is a bent T-shaped structure. So this is a bent molecule, fluorine FClF. It is in straight line. This is a 89 degrees angle is there. So this is a bent like a T-shaped structure. Then this is a bromine trifluoride. This is also the bent T-shaped structure. Bromine is there, and these are the three chlorines. Then BRF5, this is a square pyramidal. This is a square. See, we can consider square can be formed like this. So this is a square, and one fluorine is lone pair is above and one fluorine is below. So it looks like a pyramid. So the structure is square pyramidal, and this is a ClF5 square. This is also square because both are the same. BRF5 and ClF5, these are the same. So the structure is a square pyramidal. Four fluorines are in the square. This is a lone pair of electrons, and one fluorine is above lone pair is there, below another fluorine is there. So it looks like a pyramid. So the name is square pyramidal, remember. This is also square pyramidal. This is a bent. This is also bent, and this is linear. So for the 1 mark, these questions are asked for the examination on the structure. So the interhalogen compounds are the when the two halogens combine together, the interhalogen compounds are formed. One is high electronegativity and smaller size, and second one is one is less electronegativity and another one is high electronegativity. This is X and this is X dash. Then I am coming to the uses of last part of this chapter, uses of unit gases, because the xenon compounds are non-evaluative for your examination, remember. So I have not taken the compounds of xenon directly. I am coming to the last part, uses of helium, neon, argon, krypton and xenon. So out of these, helium, neon and argon, these are important. Helium, this is the first inert gas. This mixture of helium and oxygen, it is used for artificial breathing. Remember, nowadays in COVID situation, this is used, the mixture of HE and O2. Those patients having the breathing problem, for the asthma patient also, this cylinder it is used. This cylinder, it is mixed with helium and oxygen. Also, This mixture, helium and oxygen, used for the respiration by sea divers. Sea divers, these are the sea divers, means they dives in sea divers. So this is they having the cylinder of oxygen and helium. Then it is used for filling balloons. See in this picture also I have shown the picture. For filling the balloons, the mixture of 85% of helium gas is there, and hydrogen is because both the gases are lighter than air. That's why these are used in balloons. Helium and hydrogen. This mixture is used 85 plus 15% hydrogen is used. Then helium is also used for the production of inert atmosphere required for welding purpose, and it is also used for the metallurgy of some metals. Liquid helium is very important. Liquid helium is used for the producing low temperature. For the producing low temperature below minus 150, for this temperature is required for the research for the reactions. So this liquid helium is used. Then for the production of lasers also it is used in low temperature gas thermometry. For the production of lasers this is used. Then it is used also for the pressurized fuel tanks of liquid fueled rockets. For the rockets it is used. It is used as a shielding gas for arc welding. Then in supersonic wind tunnels also this helium is used. Helium nucleus is used as bombarding particles for disintegration of atoms. It is also used for the magnetic resonance imaging, MRI. For the MRI purpose also this helium is used. Remember any four uses which can be asked for the examination for 2 marks. Remember any four uses of helium. Then I am coming to the neon. You know this neon lights, discharge neon gas. It is used for the discharge lamps and neon signs. These neon signs can be visible from the long distance. Also, they can visible in mist or fog. This neon is also used in television sets, spark plug and warning signal. This is a spark plug, television sets. These are the warning signals. So we can understand the uses of neon. For that purpose, I have given these different pictures are shown. It is used for stabilizer. It is also used in fluorescent tubes. It is also used in, these are the rectifiers. In the rectifiers it is used, and for preparation of different colored lights it is used. When the mixture of neon and helium, it is used in specific amount of percentage, they can give the different amount, different types of colored lights. So different types of colored lights can be prepared by the mixture of neon and helium. Then these are the uses of neon.